So now we're on step 3, which is ETC. Don't forget that in order for Krebs and ETC to happen, oxygen must be present, floating around the cell. I think I have it right here. Okay, so we left glycolysis. Oxygen is floating around, so cellular respiration will continue. And it's going to go into Krebs and then ETC. Krebs right here, ETC right here. So this is your visual. We're in the cytoplasm. We go to Krebs, we go to ETC. So we are entering ETC. Now, even though oxygen had to be present for this to happen, this is where oxygen comes into play. So it's going to occur in the folds of the mitochondria, which is called the cristae. So you've got Krebs, which happens in the matrix, and then you've got ETC, which happens in the cristae. So once ETC takes place, oxygen goes into, or is a reactant, let's call it reactant, or what's needed, and this is exit or products, which is what's made, okay? You could change those words so you'll be consistent. Oxygen is needed, FADH is needed, and NADH is needed. So remember that ever since glycolysis, we made NADH. And again, you don't have to know the amounts. Later on, you're going to have to know amounts. During Krebs or citric acid cycle, we make NADH and FADH. All of those are the reactants for ETC. So oxygen, FADH, and NADH are going to make a total of 32 ATPs and the byproduct, which is water. So I want to go back up here, and I know I'm going back and forth a lot, but you look at the full reaction of cellular respiration. You've got glucose, which is used during glycolysis, oxygen, which is used during ETC, make ATP. ATP is made here, ATP is made in Krebs, ATPs are made in ETC, and then the byproduct, carbon dioxide, which is made in Krebs, and water, which is made in ETC. Here's the reactant again. My reactants, my products. Here's another visual for ETC. Oh, this is called the electron transport chain. I forgot to mention that before. Another visual for ETC. We've got, well, here's a full visual. You've got glycolysis. We're in the cytoplasm. You need glucose, and that makes pyruvate and ATP. Okay. Also, you've got NAD floating around making NADH. Don't forget that. Okay. It's not in this visual. Then we're going to go into the mitochondria, and we're going to go into the citric acid cycle. Pyruvates make acetyl coenzyme A, and then we go into the cycle, and then more ATPs are made. And I'm going to just draw here for you. Also, CO2 is made. And then if you really want to show a visual, you could show NAD right here making NADH. I probably should have typed this, but. And then here you're going to have the same thing. NADs making NADH. Please write that. NAD, I'll type it, I guess. All right, so I typed it. You can ignore this, by the way. This right here. So you've got NAD making NADH, FAD making FADH during the Krebs cycle. Okay? But 2 ATPs are made here. Really 4 are made here, but since it requires 2, so we're going to add that, you need 2 ATPs to break the glucose during glycolysis. Technically, it's a net. So we'll always call this net. If I ever ask you how many ATPs are made during glycolysis, you could say 4. If I ask you how many net ATPs are made during glycolysis, you can say 2. So then the last of the cellular respiration is electron transport chain. And obviously the goal is to make a ton of ATP, but you also want to know that you've got these, I'm going to copy these as my reactants, coming into the electron transport chain. So these are the electrons going into the electron transport chain, and those are the hydrogens. The hydrogens are the electrons entering the electron transport chain. And then the other product would be water. You don't have to know how many of these, but there is a lot. I mean, if I'm going to try to find an animation so you could see how many are going on. That's it for today.